Hello and welcome to POWTECH Virtual Talks. REMBE will talk about new innovative explosion prevention and protection solutions for typical applications in bulk solids and pharmaceutical industry. Empower yourself and join the talk.
Okay, so also good morning and warmly welcome from the REMBE side. We would also thank you for the opportunity to talk about this very interesting and sometimes also difficult topic, explosion safety. And Carlo and me will focus a little bit more on whole solution packages, so more or less new innovative explosion prevention and protection systems for the typical applications in the bulk and powder industry. But before we go more in detail on that topic, I would do a short introduction for REMBE. So REMBE is an independent and owner-operated company, and we have around about 250 employees worldwide, divided on 9 satellites located around the world. And the current sales figures are at around 40 million euros per year. To sum this up, our mission is to be always on our customer side. We, of course, try to be flexible and certified for all the requirements in the different industries of our customers. And of course, to be reliable, to make a full concept and the full product to be a good choice for our partners and customers. So now we will go into the methodology of explosion safety with Carlo.
Yeah, good morning also from my side. Well, this slide shows a general approach how to avoid explosions in the industry. The first step is, of course, to avoid explosive atmospheres. For example, by substitution of the product, inerting or ventilation. If not applicable, the second step is to avoid ignition sources. And if explosive atmospheres and ignition sources cannot be eliminated, constructional explosion protection should be installed as third step. Target of explosion protection is to limit the devastating effects of an explosion to a safe level and to minimize economic loss. Now we will learn more about ignition sources and preventions from Alex.
Exactly. Thanks, Carlo. So as Carlo already said, it is very important in the first steps of explosion safety to consider all the possible ignition sources. So we have here a chart with some examples like the mechanically generated sparks, which you can see here, the most common one. You can cover that topic with, for example, spark detection systems based on shortwave infrared. For the static electricity in filling a silo or unloading a truck, you can use, for example, ground monitoring systems. For the use of electrical equipment in explosion-related areas, we have explosion-proof devices and different certifications. But our question here, in addition to the fire, which topic we can cover with flame detection systems, what can we do in case of friction, hot surfaces, self-ignition, maybe also welding and small ring spots? It's also or always hard to find the ignition source where everything started. So we thought about a very, I would say, common situation. Everybody should know that you're standing in the kitchen currently at the stove, you're cooking and you're turning around only for a few seconds. And after that you see or you recognize and your nose tells you something smelled burnt here. And that's exactly the point. So after that, the visual check with your eyes is following, which means you check if there is smoke or if there's fire. So at exactly that stage of smoldering material, you can't see fire and you can't see smoke. But that is exactly the situation we want to take care about. So we work now with some preventive measures like the GSME-FIRE gas detection and a hotspot temperature detector. Before we go a little bit more into the detail of the different applications, a short introduction to both components. So the hotspot is more or less a very compact camera. You can show here on my, you can see here on my video, and it is based on long-wave infrared. Long-wave infrared means we are continuously measuring the surface temperature of everything which is inside of our field of view. So the benefit here is that we not only say there is a fire or not. Our evaluation options deliver the possibility that we can say precisely where the hot material is currently. So our complete field of view is divided in different temperature zones. And for each zone, we can set, for example, a temperature limit, which means when we reach the 50 degrees, we will have an alarm by depending on potential free contact or something like that. Additionally, we can use zone differences, for example, to combine zone A here on the lower left side and zone B on the lower right side to do a combination and say the maximum allowed temperature difference between these two zones is to be allowed at 20 degrees. So everything which goes about 20 degrees or above 20 degrees will create an alarm. And the last possibility of evaluation is using fluctuation values, like when the temperature is increasing or falling too fast in a defined time period. To sum this up, the aim of this is to allow a very early process intervention if necessary to avoid any bigger damages. In addition to the camera, we also have a very compact gas detection system. Maybe you know the common ones which are focusing on CO. We thought that our mission should be CO is not everything, because every kind of smoldering material releases also different gas types. So to cover all them up, we thought about a very simple solution, which is based on semiconductors to measure carbon monoxide, hydrogen, and a mix of hydrocarbon and nitrogen oxides. So you can set a maximum concentration limit, like for example, 50 ppm for CO. When this is reached, you will get an alarm, but you can also do some kind of combination between all the different gases. So you can say the requirement for an alarm is to have 50 ppm CO, 10 ppm hydrogen, and another 5 ppm hydrocarbon, for example. So you are more flexible in evaluation how your process is running. So all in all, I would say we had a lot of ignition sources which weren't covered at all. And now we can say everything which starts with a small increase in temperature, like friction or hot surfaces, self-ignition and smoldering spots, or which starts with an increase in the gas concentration or in creation of fire gases, we can cover with the temperature and the gas monitoring systems. So why you should do that is a very simple point. I would say the sooner, the better. Here we have something like a timeline. We have divided it in 4 different stages. So in the first stage, imagine you have smoldering material. Smoldering material leads to an increase in temperature. Additionally, you will have something like a creation of fire gases. So at this stage, you don't have any visible smoke. So you're way early. After that, we have the... Oh.
Please mute yourself.
I already did it currently.
Thank you.
So after the first stage, the following one is the visible smoke or the sparks, which means you have visible smoke, can detect it with an optical smoke detection system or with the spark detection system. After that, the flames can be covered by flame detection system. And your last option in case of a fire is, of course, extinguishing it. But when we have the possibility to detect temperature increases and fire gases in the early stage of fire and explosion prevention, so in the first stage, we can avoid all the following 3 stages and can therefore save a lot of time and save a lot of money due to avoiding higher damages and higher plant downtimes. So after that short introduction into the topic of explosion prevention, we go over to Carlo to hear something more about the explosion protection.
Yeah, thank you, Alex, again. This slide shows the different options of constructional explosion safety. Options are explosion pressure resistant construction, there's a typo, explosion venting or explosion suppression. All options are existing in the industry. Just to give you some examples, pressure resistant design is often used for smaller vessels, especially in the pharmaceutical industry, or for ultra low minimum ignition energy like we have in the metal industry. Explosion suppression is used often when we deal with indoor installations with large volumes, as an example, spray dryers, or when you, of course, deal with toxic gases or substances. Very important, all of them shall be combined with explosion isolation to avoid propagation in order to minimize the pressures up and downstreams. If isolation is not given, it may lead likely to horrible accidents and secondary explosions. Especially, we are on a daily basis very often on site in the plants, especially in the older installations. Explosion isolation is often not given. This led to numerous strategic accidents in the industry, also in the recent years. Now we will show you some safety concepts for typical applications in the industry.
Exactly. So the first one we picked out is the classic silo application. So we are on the goods entrance, and now the first, I would say, task is to check what ignition sources can be risky in this situation and what has to be done to prevent the ignition sources, or more or less what need to be done to use the explosion protection as an airbag in the last case. So we are starting with our ground monitoring system at the goods entrance for grounding the truck to avoid electrostatic discharges, which can lead to an ignition of the dusty cloud inside of the silo, for example. Depending on how the material goes into the silo, we can also check the surface temperature of the material inside of the silo with our camera, as it is certified for the usage in zone 20 and zone 0. Additionally to that, of course, to have a good overview and a good monitoring, we also use the GSME-FIRE gas detection to see if there is any increase in CO, in carbon, in CO, in hydrogen and hydrocarbon, for example. And the last option is, of course, not only to check if hot material is going inside of a critical zone, also coming out of a critical zone to make a new potential ignition source for the next one. So we also check the temperature from the outside with our camera. When there's, I would say, a smoldering ember inside of the lower part of the silo cone here, the temperature gets transported quite easily to the outer wall, where we can detect it in an early stage.
Okay, well, most silos in the industry are protected by explosion venting because of its volume, always in combination with explosion isolation. Here, the pneumatic filling line is isolated by a quench valve in order to avoid any pressure shock in the direction of the truck. And the explosion isolation of the material outlet is provided by a rotary valve.
The next application, here we show mechanically conveying system, so a bucket elevator, but it could be nearly any other system like a chain conveying system, a screw conveying system, or something like that. But the, I would say, application is always nearly the same. Because as I said before, we try to avoid that hot materials, smoldering materials can get into an explosion risky zone. So therefore, in the first step, we are checking the outlet of this elevator or of this conveying system of hotter materials. So as soon as we see that there is a small increase in temperature, we can say we shut down the conveying process and check for maybe that smoldering ember to, I would say, put it out of the process, to get it out of the process, and without any long interruption, start back again. The second option is to use our gas detection, the GSME, most times in the highest point or in the head of the conveying system. because due to the movement inside of the conveying systems, the fire gases will, in most cases, will be collected in the upper part. When we have something like this here, so an aspiration line at the conveying system, we can also say that we use an additional gas detection in the filter, but we will see a little bit more in detail about that later. And for the prevention, I would say this is a full concept, and now Carlo will take over for the constructional measures.
Yeah, well, most conveyors are protected by explosion venting as well. One reason is, of course, the low design strength. And last year, we launched a new product, the Q-Ball. And this Q-Ball is a flameless venting device, and it is dedicated for mechanical conveyors like here illustrated bucket elevators or chain conveyors. And the advantage of this product is the compact design, and it allows operators easy retrofitting of existing installations in order to minimize safety areas. Explosion isolation here in this illustration of the material inlet and duct outlet is provided by our cubic system. This is a chemical barrier system, and isolation of the aspiration line to the dust collector is provided by a quench valve. Both systems, cubic and QV, are able to isolate explosions in both directions.
Our next application is, I would say, quite risky, because we are not only working in conveying or conveying the material. In this case, we have direct impact on the material. So we are crushing, milling, or grinding the material. We have a lot of pressure and a lot of friction, which can always lead to an increase in temperature, which can then lead into a self-ignition, for example. So depending on the whole process is looking like, we use our gas detection system. This is, I would say, a quite new modified version for the usage in clean air pipes after total separators, dust collecting systems, whatever, to see everything which is connected to this dust collector or to this total separator can be monitored or covered, because every kind of gas which is getting created in the different components will end up here in the clean air side. So that would be the first one, to give a good overview of the process. And the second one, of course, is depending on when we have a bigger mill, we can check the outlet of the mill of temperature increases. In this case, we have a small pin mill and a pneumatic conveying line directly to the total separator. So we often do it here that way, that we say everything which goes out of the total separator gets covered or monitored by temperature monitoring, to assure to be sure that there is no self-ignition, depending on the material, of course. So now we will go over to Carlo again for different constructional measures.
Well, in this concept, the pin mill is designed explosion pressure resistant, and the separator, the dust collector, is protected by explosion venting. Here a Q-box is illustrated. This is another flameless venting device, which is dedicated for larger volumes in the industry. Explosion isolation again is provided here between pin mill and dust collector by our cubic, our chemical barrier system. Also a quench valve would be applicable. The material feed and the outlet is protected by rotary valves, and the clean air ducting is protected by a Ventex valve. This is a pressure resistant valve which isolates explosions as well. The air inlet of the mill is often protected by a Ventex valve as well. Last year, we also designed some new flame arresters, which are applicable for these kind of applications, to be installed in the air inlet or ventilation slots of the grinder of the mill, in order to protect the workers against flash fires caused by an explosion.
So we already had it in our last slide, the total separator or the dust collecting system. Very common application because everywhere you can find dust, you will also find a dust collector. So as I said before, it is a very good opportunity to check of fire gases or to implement a check for fire gases at the clean air outlet of the filter, because everything which gets sucked out of the production process will end up here at that point. And therefore we have a concentrated gas flow, which is perfectly for measuring such concentrations. This is for the prevention, the only, I would say, most suitable measure. And therefore, exactly in the filter system, we are focusing on the constructional measures again.
Explosion protection of dust collectors varies from industry and application. All of these options are to be seen in the industry: pressure shock resistant design, suppression, venting. To specify the explosion isolation in the raw gas, I think it is necessary to distinguish between aspiration filters and total separators because of different dust loading. For aspiration filters, we recommend the Redex flap. This is a flap valve. And for the total separators, we recommend the cubic, the chemical barrier system, or the quench valve because of the higher mass flow and the lower pressure drops. Also for retrofitting, sometimes it's better to have a quench valve instead of a flap because of the high pressure drops. The clean air side here is protected by a Ventex valve. This is especially necessary when you consider to recirculate the air to minimize energy costs. If you have just ambient air, normally there is no explosion isolation given. Okay.
The time is running.
Exactly, that's nearly the last slide. So we already showed it twice before, and now a little bit more in detail. This is the gas detection system, so mainly based on the fire gas detection we call GSME. We modified it for the usage in clean air pipes, especially for dust collecting systems. Because as you know, the gases, when they get conveyed, are only in the center of the pipe. So we get it out by putting 2 Venturi pipes into the process line. And by creating an underpressure at the behind pipe, we will also create a suction at the small holes we have in our long pipe, which is going through the complete diameter of the clean air pipe. So this leads to a continuous, I would say, airstream or gas stream to our gas detection, and afterwards to a flow back into the process line. So we have something like, I would say, a very representative and reproducible way of monitoring the gas concentrations.
Okay, the last slide. Now I rush through. It shows our portfolio. And besides manufacturing, we do also offer consulting on site. And we have also a test center. I think this is really important for a manufacturer, as Feig and Artex already pointed out. And of course, we do also have a service team which is able to support you to install, commission, and maintain the installations and systems. Okay, so we are through, and we are looking forward to your questions.
11:10. Perfect. Thank you, Alex and Carlo, for the presentation. And you mentioned also mechanical conveying, which is very interesting for us. You know, to the audience, I'm from the German Bulk and Powder Association. So, and our focus is on the equipment for the bulk and powder industry, and about our topics is in processing and also for sure in explosion protection, but not so deep as maybe in other associations. But we are working on it, and thanks again. And I have the first questions are on the chat, but I have a question first because you mentioned first the sensors, infrared sensors and hotspot. So these sensors, how sensitive are they? And do you collect the data to bring them in the cloud and then maybe to use for the surveying or other purposes?
That's a very good question to demonstrate a little bit the accuracy of such detections. So compared the hotspot here compared to a flame detection system or a spark detection system, the spark detector says, okay, there is a change in the light situation, I would say, and therefore we will create an alarm. The flame detector will say, okay, in our complete field of view, there is some hot material, some hot gases or whatever above 400 degrees. So we will need to signal our plant processor that there is a critical situation. We going a little bit further and saying we are not measuring 400 degrees or upwards. We are saying we are measuring from 0 to 200, so that we can see from each temperature. So for example, from 20 to 22 degrees. The difference of two temperatures of 2 degrees can be seen, and therefore already small increases can be, I would say, detected and evaluated. A simple example for the gas detection system, if we see the GSME detection is mounted in something like a garage, and you have an old-timer car in it. When you start the old-timer car, the GSME detection will immediately say red alert. So a lot of fire gases inside of here. So therefore, this is, I think, a very good overview example to see or to show the accuracy of it. I think more or less this covers all your questions, Jochen. Am I right?
Yeah.
Okay.
There are 2 more questions, and I guess we have the time for it. The first is from Max Petri. Please open your mic and ask directly Carlo or Alex.
Hello, I'm a student and I'm interested in this explosion protection in the explosion protection industry, and I just saw on the website that I think it was 1 month ago that the cubic was not available, but some time ago it was available, and so I was wondering if it is now available or what is the current status of it.
Well, the cubic is available. We sold a lot of devices already and installed them worldwide. So
okay.
Feel free to place the order. So we no, it was a development which took a few years. Some years ago, we worked close together with IP, the manufacturer of a suppression system, but they canceled the friendship with us. So it was the decision of our management to invest or to develop an own design, and now it is available. Not for suppression, not for large volumes, but as a chemical barrier system and for smaller volumes. Definitely, yes.
Okay, thank you.
You're welcome.